Hey there, welcome to dotnetFlix. In this episode, Eduard Keilholz is going to talk about hub and spoke networks and Azure networking. Maybe you've worked with Azure before, and if you go into the realm of networking, it can be a little bit complex. And you have to do it securely and make sure that all your resources are protected. So I think this is a very important subject. So Eduard, maybe you can take us along the ride and talk about hub and spoke
Sure.
networks in Azure.
Yep. So yeah, let's go. Well, you already mentioned it. And I think that Azure networking is not necessarily a security measurement, but it is it opens the gate to security.
Hmm.
So and it's always a very hard topic to talk about because everyone chimes away when you start talking about networking. While um, in fact it can be as simple as setting up your Wi-Fi network at home, and it does bring you a lot of security features. So it's really worth taking a peek at networking in Azure. And yes, today I will show you what a hub and spoke network is in
Cool.
Azure. So yeah, this is my screen. This is today we're going to do a presentation only.
Hmm.
And that is because there's just a lot to cover, and I hope that my story is clear enough. And if not, then the presenting guys will chime in and ask clever questions, and hopefully I can answer them. So well, yeah, this is me. I'm a cloud solution architect at for.net, doing awesome stuff. Uh, but yeah, not that important for this story because we're going to talk about networking. And let's first um, hold here for a second. So why do you want a VNet in Azure? Um, because it brings a lot of complexity and maybe some overhead, and it causes limited accessibility. For example, in your development environment, when you're used to just hitting F5 in your development environment to start up a debugging environment, you would, for example, like to connect to a database that sits in Azure. Now, when that database is integrated in a network, it may be protected from a network traffic perspective, from traffic from your debug session. So you cannot access your database. That can be a problem. You have some service dependencies, and maybe it is just hard to set up a network, and you struggle with misconfiguration. On the other hand, already mentioned it, you have a security pro, which is, and I think that um, VNets are basically the gateway to securing your cloud environment. But there's a lot more. You have this private communication, so it allows services to communicate with each other privately. So that's through an internal network. So the traffic will never end up on the public internet, which makes the traffic a little bit safer. You can isolate resources in a network, and there's a lot more. And mostly, I think that the improved performance is um, networks can allow you to configure the internal network traffic a little bit more optimized compared to when traffic needs to go to the public internet first and then resolve a certain resource to an IP address and then navigate back into the Azure network and access the resource. If you do that, if you have all your resources integrated in the VNet, they can access each other from within the VNet, which is a performance improvement. Now there are a lot of network topologies that you can use in Azure. One of them is the hub and spoke, but you also, for example, have a mesh network. And in this case, we're going to discuss the hub and spoke network because I think there are a lot of advantages of using a hub and spoke network. And it typically looks like this. So the hub sits in the middle, and there can be one or more spokes. So in this case, there are eight spokes, but with hub and spoke networks, these spokes can typically come and go when they want. And I think these networks can be very powerful. For example, if you have a multi-tenant system and you want the tenants to be isolated from each other, then you can create a spoke network and have a system dedicated to a certain customer with data dedicated to a certain customer in one spoke, and that disallows communication from those services to other services in other spokes, and thereby disallowing accessing traffic of other tenants. And that is because spokes typically don't communicate with each other. So the hub is there as a single point of entry into your network. That means that all external traffic from the big net internet comes into the hub network, and the hub network will try and redirect the traffic to the correct spoke. And there are several ways to do so. But also, what I think is very powerful is to use a hub and spoke network for your deployment environment. So let's say that you have an internet system that you want to host in Azure, and you want to deploy that through a deployment environment with dev, test, and acceptance and production. Then the dev, test, acceptance, and production can be spokes. So you have 4 spokes there. And why do I think that's awesome? That is because you can create a VPN connection from your local development environment to the hub that allows you to still access the resources from your development from your local development environment. So when you press F5, you can access resources in your cloud dev environment from your local dev environment. Does that make sense?
Yeah. So is it possible then to go one step further and say I can VPN into the hub, right, to get into
Yeah.
my dev environment, but
Mhm.
I'm not allowed to go into the production environment. I only want to be able to go into dev test, maybe acceptance.
You can configure that because it is a little bit hard to see, but between the hub and the spokes are black arrows. I should make them
Hmm.
white. Um, but the black arrows are what's called a network peering. And with that peering, you can configure what type of access is allowed. So you can a peering is always 2 sides, so always from the hub to a spoke, and then from the spoke to the hub, back to the hub. But you can configure both ways what type of traffic is allowed. So you can also disallow traffic on one of the pairings, and then you have one-way traffic from the hub to the spoke. But you can also do that on different levels. For example, if you have this VPN connection, you can on the hub allow that on a certain pairing, this VPN connection may be forwarded, and on a different pairing, it may not be. On the other
I
side, on the
see.
spoke, you should also configure the spoke that it accepts the VPN traffic. So again, this is two-way, but yeah, it's configurable to allow traffic on the development environment in your cloud, and disallow traffic to test acceptance and production, for example, if you like.
Nice.
And one more question, Eduard. You're
Yeah.
talking about a VPN from your local development environment. I can imagine that you are a developer inside of a corporation that has a corporate network. Could you then also use, for instance, site-to-site VPN between the corporate network and the hub, and then you have to route the traffic over the corporate network over the VPN? Is that also possible, or do you always need to have a site-to-site or a point-to-site VPN from your local development machine?
All right. I have never set this up, so
Okay.
I don't know for sure, but I am pretty confident that you can.
Okay.
But I never did it, so I'm not going to put the Eduard stamp on it. So this is the truth.
the
Um,
the Keilholz stamp of approval.
but but I'm pretty confident you can. Yes.
Okay. Okay. Great.
So basically, this topology is there's always one hub, and there can be one or more spokes, and they can come and go when they need to. So why do you want a hub and spoke network compared to other networks? Well, the answer is because you have this single hub. You have centralized management of network traffic coming in. For example, we already had a chat about the VPN connection. That is one one type of network traffic that you would like to manage. But also, in my example, that you create this website or web API or maybe microservices architecture, I don't care. You want to configure how public internet traffic arrives at the hub, what you do with it, and how you want to route it to the correct spoke. Um, and that also complies a little bit to the fail fast principle. So, for example, if you use the WHF or WAF firewall, you only have to set it up once. That's in the hub, and then you can immediately identify malicious traffic and fill the request from there. So the traffic doesn't even arrive at your spoke and, for example, bother your service process. So I think that's really cool. You have one place where you configure your routing. So when the network traffic arrives at the hub is clever enough to immediately know what spoke to redirect the traffic to. You have enhanced security because you can really protect the hub against malicious traffic because you have only one way of one central point of managing it. It's really easy if you really tighten that connection to the let's say most secure way that works good for you. You only have to do that in the hub. It is cost efficient because the hubs have only connection to a spoke, and then compared to, for example, a mesh network, you have a lot of connections going on, and that's a lot of connections to maintain, which is a little bit harder and not cost effective. And you have simplified troubleshooting because the network topology is really not that hard. You have the hub and then a couple of spokes and one line from a hub to a spoke. All right, so this is typically an example of a hub and spoke network. And on the top you see a hub, and on the bottom you see a test and production environment of a software system. And in this case, the hub contains a VNET, which is the top icon. What is it? Smaller than a larger than icon with the three dots that stands for VNET. And in that VNET, we have, in this case, App Gateway. And App Gateway is typically a service that you would use to control traffic that comes in from the public internet into your network. And App Gateway can have, let's say, two endpoints, where one endpoint would be the public internet, and then there's a firewall in the middle, and the other endpoint would be your internal VNet. And by configuring the firewall, you basically configure what traffic you want to allow into your network. One other example could be front door, for example, and the difference between the two is that App Gateway lives on a certain location while the front door lives on the edge. So the way that front door integrates into your VNet is a little bit different. But you can compare these services. So this lock icon, this is the VPN connection. So this in this example, we're going to create a VPN connection between my local development machine and this VNet with the VPN connection. So this one needs to be there. We have a DNS zone, and this is a private DNS zone. And as always, if something fails in your network, it's DNS. And we're going to talk about the DNS in a little bit, because DNS in this setup is, I believe, the hardest thing to set up. And to be able to resolve addresses, DNS is a domain name service, I believe, and it translates domain names to IP addresses, because networks only know IP addresses. So whenever you type www.google.com in your browser, you go to a DNS server, and the DNS translates that to an IP address, and from there on, a computer knows what to do and what server to address. And this DNS resolver allows you to resolve host names from your internal network so that you can access those services from the internal network. But more on that later. And then we have this nice firewall in place, which is part of the app gateway. And on the other side, we have the test and the production environment, which look equal. They also have a network, and there's a pairing between those networks, and that is important. So those are the black lines between the hub and the spoke of the previous slide. Luckily, I make them white in this slide. And then a couple of services, and those can be whatever service you need to host your system. Now, the VPN connection. And this is just a VPN connection that allows me to connect from a network to my virtual network in Azure. And in this case, we wanted to access internal resources in the VNET. And yeah, for this setup, because we use the hub and spoke network for a deployment street, is that the correct word in English? I don't know. We want to be able to develop from our local machine and have a good developer experience from there, and this VPN connection allows you to do so. And yeah, like we already discussed, it may be possible to create different connections to your VNet in Azure, so to the hub network. But yeah, I'm not sure how to set it up at this time. I will investigate it because I think it's a good point. Then we have this private DNS zone. So we use the private DNS zone to resolve host names from your internal network to an IP address that also is in your internal network. And that is necessary because Azure uses a central DNS, and that central DNS can only resolve public IP addresses. It cannot resolve internal addresses. So we need private DNS zones to register host names to an internal IP address, and we also need a mechanism to be that allows us to resolve the host name to an internal IP address. Now this part is quite hard. So for example, if you have a SQL Server database, a SQL Server database would typically live under the name of your SQL Server, and then I believe .databases.windows.net or .azure.net, I'm not sure. And it's this last part, .databases.windows.net, where you would create a private DNS zone for. So if you have a different service that you also want to integrate in your network, let's say a storage account, which typically live under core.windows.net, I believe, then you need to create an additional DNS zone and also link that DNS zone to your network. So you can have multiple DNS zones for different domain names, but you should only have one DNS zone per domain name in your entire hub and spoke topology. All right, I hope that's clear, because it's this is hard to understand. So if you have 20 SQL Server databases, you want to integrate those in networks, you would create one private DNS zone, and this one private DNS zone would typically be linked to your all your networks. So that's both the hubs and the spoke networks.
Yeah, and then if I also want to have storage accounts which have a different domain, I would need a second DNS zone, and I can connect that DNS zone to every VNet that I'm using to host my storage accounts, right?
Yes, and then you add Cosmos DB, another private DNS zone, and then also link that to the hub and all these spokes. Now, to make this a little bit more visual, I created, in this case, two private DNS zones. And those DNS zones live outside your network, but they have a link to your network. And they can have multiple links. So in this case, this is, let's say that the square area in the middle is my hub network. Both private DNS zones are now linked to my hub network, but I can also add these spokes around it and have the private DNS zones linked to those spokes. Now, what happens if I connect to this network and I try to resolve, let's say, the host name of my SQL Server? What typically happens is that my machine would consult the Azure DNS, and the Azure DNS would resolve the public IP address. But unfortunately, my SQL Server is integrated in my network and it's protected all well from external network traffic, so I cannot access that SQL Server from my external network, even when the VPN connection is open, because still I consult the Azure DNS and I get the public IP address. So then still when my VPN connection is open, I can still not access my SQL Server because it tries to access the SQL Server from external internet traffic. And so to deal with their problem, there is a fairly new service. I believe it exists for about a year or so, and it's called the private DNS, the Azure private DNS resolver, or the DNS private resolver. I'm not sure. Either one. Oh, it's on top. Azure DNS private resolver. It's the title of the slide. How could I have known? So what happens is that this DNS resolver tries to resolve the IP address of the hostname that you're looking for. And if it cannot find the IP address, it will forward the request to the Azure DNS, which will then, in this case, again resolve the public IP address. But the fun thing of the Azure DNS private resolver is that it can have an inbound endpoint, and I always compare that with a tentacle of an octopus. It has a tentacle that lives inside your VNet. So now it will be able to resolve the internal IP address of the resource that I'm looking for. So instead of this 168 blah 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 IP address, I get my internal IP address 10.x.x.x, which is the internal IP address of my VNet. So this is really important to understand. And if you want your DNS and hostname resolving correct, this is, I think, in this entire network setup, the hardest part to understand. Now, to integrate resources in your network, there are basically two flavors. One is service endpoints, which is a way of fairly easily integrating your services into a VNet. And you have private endpoints, which are a little bit more sophisticated, but they also require you to maintain your network environment a little bit more. But I don't know if you like infrastructure as code. I do. And I typically write all the resources that I create with infrastructure as code. So that makes it a little bit easier to maintain everything, and it prevents you from making mistakes. So I have a demo that is available, but I cannot show it. And that is because the demo environment is not fully ready yet, and it will be available at the Techorama conference, and I have a meetup, I believe Azure Thursday, that's called, at the beginning of October, where I will show the demo. And in the demo, I have a hub and spoke network set up, so we will quickly go through the resources, how they are set up, and how the connection, so this peering is created, what resources live in the hub, and I created a spoke network, which is basically empty. And then in this demo, we go ahead and integrate a storage account in the spoke network, and then we will see what happens with the production environment that's currently running. We will also see what happens with my development environment. So I will F5 on my Visual Studio and see that now the requests are failing because this resource is protected from a network perspective from my external internet traffic. Then we will integrate the web app also in the spoke network, and we will then see that this website will again be able to connect with the storage account because they live in the same network, and these integrations are configured so that the connection from the web app to the storage account is allowed, and still my local environment won't work. Then we're going to disable uh, all access to the storage account, and then everything will fill again. So the website will fill, and the local my local development environment obviously will also fill. And then finally, we create a private endpoint. So that basically means that we switch from a service endpoint to a private endpoint. And then the website works again, but then still my local development environment fails. But now when we open up this VPN connection, which is just a click of a button, hit connect on a VPN connection, then you will see that your local development environment works and is able to connect with the storage account. And I think that's it in a real fast, within 30 minutes story.
Yeah, thank you so much, Eduard. So do you see do you see a trend towards more security with the projects that you're doing for many different customers?
Oh yes, for me, yeah. I started this, I believe, four customers ago, and to be honest, the network that I built up starts to evolve over time because I make it better and better and more efficient. So there's a learning curve, but the first setup I really bumped into to a fairly steep learning curve. But that
Mhm.
was all in my mind. I just started doing it, and then everything became clear. And the hardest part was resolving internal IP addresses that live in the network while I'll still have the VPN connection open. And I couldn't understand why it still resolved to the external IP address.
Right.
So that was really a struggle for me. And once I understood what was going on, that was still the time that the DNS private resolver was not there yet. So you had to set up a VM and host a DNS resolver yourself or DNS forwarder yourself. And now that's very much that became very much easier with the DNS private resolver because it's just a resource in Azure. You provision it and you create this nice tentacle into your network, and you can
Yeah.
resolve to internal IP addresses.
Yeah. Yeah, and you're coming to this from a developer perspective, right? You're not a hard code infrastructure guy. You're
Not
also,
really infrastructure. Yeah,
yeah.
it's a little bit. I have two hats, so to say. I am a developer, but I'm also a cloud architect.
Hmm.
I consult for companies how they should move their current workloads to cloud environments, and that is where these kind of networks chime in.
Right.
Because you
Yeah.
try to do the best you can for customers and then make it as safe as possible for customers. Um, and yeah, again, I think that VNet is step one to security.
Yeah, because I think it's really important for developers to also know about these things. Because if you have a larger organization, they will probably have like a platform team and they can work with you to figure out what's the best way to create our landing zones and how do we onboard
Mhm.
teams and stuff like that. But I also see a lot of smaller organizations where basically there's a DevOps team that do everything. And then sometimes there are some infrastructure experts on that team. Sometimes there aren't, and then it's really good to know that it's not safe by default, right? If you
No.
just go to Azure, spin up some resources, then you're not secured at that network level. So even for a let's say a regular developer, it's important to at least know some of these basic things about infrastructure and well, other
Yeah.
things you told us about, like infrastructure
Yeah.
as code.
And even if you've connected all your resources to this VNet, then also what my experience is that most of the time the default setting is still that these resources are also still available over public internet. So
Yep.
also all your resources need to be configured to not be reachable over public internet, but only through the VNet. And that's a step that is often forgotten. And then you have this great network infrastructure, and it all looks secure. but still these resources offer an endpoint on the public internet. So you have to be
Yeah.
really aware of where you open up stuff towards the internet, and you want to close it down as much as possible.
Yeah,
So
if you
yeah, it's,
can go to back to my slide again, which is currently open, then in the demo we move the storage account into the Spoke network,
yeah.
as with the web app. So the web app now lives in the Spoke network, and it is able to access the storage account using the internal network traffic within the Spoke network. But I didn't tell the web app to disallow traffic from the external internet. So in this
Mhm.
case, this web app still accepts public internet traffic.
Yeah.
So that's a good point that you make there.
So what are your thoughts on a service like API management, Edward? Should I put that in the hub because it's basically
Oh yeah,
a connection to the external customer, right? Or should I
yes.
have multiple API management instances in different Spoke networks?
All right. Um,
It
oh man,
depends.
it's a rabbit hole. You opened a rabbit hole here. What I typically do is add API management in the Spoke network, but API management is quite expensive.
Mhm.
As you may know, and
Yeah.
I believe they doubled the price a couple of months ago.
Did they? Oh,
Yeah.
Yeah, it was 1,200 euros. I believe it's 2,500.
No.
I should go look at my Azure bill then. The thing I did know that maybe it was in there for longer, but I don't remember seeing it earlier, is that they now do offer VNET integration with the developers queue. So at
Yeah, they
least
do.
for
That,
dev and test environments, you can
yeah,
use
that,
a
that that
Yeah,
has
fairly
been for a
cheap
long time.
SKU. Yeah.
Because that's
yeah,
what we always do. What we do is for non-production environments, we deploy the developer edition, and you can then do VNet integration. And then
yeah,
what we do often is that you have an API management per spoke, because you want to have a development API management and a production or a test. And then you route all the traffic to these API management instances over your application gateway. So most of the time,
yeah.
the application gateway or the Azure front door, as Eduard said, that is the access point for external parties. And then
Exactly,
you route it through backend pools and stuff like that to the right instance, based on the URL or based on a host name or whatever.
exactly.
Right.
But there's one problem with this setup,
Hmm.
and that is that you cannot change the configuration of App Gateway.
Yeah,
So when
that's
a
really
new
annoying.
yeah, so when a
So
new
what do you
spoke
mean? You cannot change the configuration. You cannot change it without downtime, or
Yeah,
am I just stuck
yeah,
for eternity?
yeah,
you now you're not stuck for it. Yeah, just go home.
yeah,
No, what you want in this network setup is that spokes come and go as they like.
yeah,
So you want API management to be able to understand. Okay, there's now a new spoke, and whenever network traffic comes that complies to, I don't know, this rule, it needs to be redirected to that spoke network.
yeah,
Yeah.
You cannot do that with gateway. So that's a one-time setup, and you cannot not change that setup using infrastructure as code.
Mm.
So the solution is to either move API management to your hub network,
yeah,
because there you can change the configuration while it's running, and then you can add spoke endpoints to your hub.
yeah,
And that also brings the advantage that you have only one API management, which is also cost effective. The other solution that I have is to, for one time, as an exception, move app gateway to the spoke. And then you have one network entry
yeah,
for the external internet traffic to your API that live in the spoke network. And that is against the rules of the hub and spoke topology, because you typically have this hub for as a single point of network entry. But because there's no way at this time, no way to control that from an automated way using infrastructure as
Mm.
code, you have to deal with it some way, and you have
yeah.
to compromise somewhere.
It is that you can, with Bicep, of course, you can deploy an application gateway, but you have downtime. And the really crazy part is that everywhere where you look with Bicep, you have certain resources with child resources, and you can update individual child resources. And an application gateway contains lots of child resources. Like I said, it has backend pools, and it has routing rules, and it has firewall rules. It has probes, health probes. But you have to deploy it all at once. You cannot update individual parts. And once you do that, you will have downtime, and your complete application gateway will be offline for some time, and nothing is available. And if that is your hub network, then, well, basically everything is offline for a couple of minutes. So that's, I really am still, when I was working with this, because I've had the same journey as you, Eduard, and I was really flabbergasted by this. Why this, this resource that has to give you access to resources will go offline when you reconfigure it. It's really, really strange. But maybe they will improve that in the future. But
and typically, what you don't want is that this hub network doesn't know about spokes when they come and go. The only thing that you want is a spoke to be able to configure something in the hub. So, hey, I'm here, and that's it. And that is exactly the part that you cannot do in the app gateway of using infrastructure as code.
So Microsoft, if you're listening, please fix the resource manager for application gateway. Pretty please. Cherry
3 MVP votes here, so let's do that.
Okay, so
the question
Eduard.
that Microsoft is listening.
Yeah, probably.
You never know.
Yeah.
At least once a year, around March.
So, Eduard, thank you so much for talking, taking the time to talk to us about all this great networking stuff.
It was real fun. Yeah.
Enjoy your talk at Techorama. That's always a really great conference. So
I have a couple, and I saw that we will meet up at a couple of conferences as well.
Oh yes, we will. We definitely will. And
so really,
we'll have a good time. Oh, and we will add a link to your demo code once it's available after Techorama. We can add it to the notes of the YouTube video.
Yeah, cool. So the demo code is basically a repository that contains the start position of my demo. So that's the hub network, the spoke network, and the spoke network is empty, so you can do the exercise of integrating the storage account and the web app yourself, which is fun.
Cool. It's homework.
Yeah.
But there are bicep scripts in there, right? So it's all infrastructure as code.
Sure.
Yeah,
it's just
the way it ought to be.
Yeah. So there are two commands. One is for deploying the hub network, and the other one is for the spoke network.
All right. Sounds great. So thanks again to everyone watching. We hope you enjoyed this episode. Please like it if you did. Be sure to subscribe so you don't miss any future episodes. And we'll see you next time.
Click on the thumb and the bell.
Exactly. Bye-bye.
Bye-bye.